Right, so this is the core 4 homework on implicit differentiation.
It just fell over a bit.
The points P and Q, you have to be really polite when doing this question. Mind your P's and Q's. The points P and Q lie on the curve of the equation 2x squared minus 5x5 plus y squared plus 9 is 0. The tangents to the curve at P and Q are parallel, each having gradient 3/8. Show that the x and y coordinates of P and Q are such that x equals 2y. Great, so we're going to differentiate it. It's all about gradients, so that means we have to differentiate it. So we're going to differentiate everything with respect to x. Should we write all this stuff out? It's alright if you do it like this. There we go. Equals 0, because differentiate 9 equals 0, don't we? So we get 4x out of that bit. Here we've got, did it fall over then?
No.
Oh, okay,
Cool.
good. It's cool. Right. Here we've got a product, 5x times y. So that's the first times the derivative of the second plus the second times the derivative of the first, which will be 5. And then we've got the derivative of y squared, which, as you remember, would be 2y dy by dx. And all of that is equal to 0. So let's try and tidy this up a little bit. We've got 4x minus 5x dy by dx. Oh, aha. Minus 5y plus 2y dy by dx is 0. We need to collect together the dy by dx bits. So we've got 2y take away 5x dy by dx. And we've got 5y minus 4x. That's the other bits, once we move that over. So dy by dx is 5y minus 4x over 2y minus 5x. Of course, that is exactly the same as 4x minus 5y over 5x minus 2y, if you have it the other way around. But you can use that, didn't you? Right, so we've just differentiated it. Show that the x and y coordinates of P and Q are such that x equals 2y. The tangents to the curve of P and Q, each having gradient 3/8. That's the key bit. So at P and Q, the gradient is 3/8, which means that 5y minus 4x over 2y minus 5x is 3/8. We need to tidy up this equation now. That is 8 lots of 5y minus 4x equals 3 lots of 2y minus 5x. Well, let's see what happens with this. 40y minus 32x is 6y minus 15x. So, what have we got? 34y is 17. Oh yeah. And that's nice, isn't it? Because if we divide by 17, we get 2y is x. Is that what we're supposed to get? X equals 2y. Hence, find the coordinates of P and Q. Well, what we now know is that at P and Q, two things are true. This is true. X equals 2y, and our original equation is true because it's on the line. 2x squared minus 5xy plus y squared plus 9 equals 0. I remember that right. Yep. So now we've got simultaneous equations to deal with, and you could do it either way. It's probably easiest just to sub in x into there. So we've got 2 times 2y squared minus 5 times 2y times y plus y squared plus 9 is 0. We've got quadratic in y, 8y squared minus 10y squared plus y squared plus 9 is 0. which simplifies to give us minus y squared plus 9 is 0, or y squared minus 9 is 0. I'm making hard work of this, aren't I? Which is different to 2 squares. So y is 3, or y is minus 3. And of course we had x being 2y up here. So x would be twice y, and x would be twice y. So the points are 6, 3, and minus 6, and minus 3. They are P and Q for your final marks. There we go. 8 marks altogether. Quite neat. Everybody happy-ish?
What have you got? 2 of the things right, 2 of the wrong.
As in 2 of the coordinates.
Yes, I've got the X one.
Yeah, give. I think we've got plus or minus 3 there, haven't we?
No, actually, no, that is right, actually.
Yeah.
It's got an extra.
So just not
Second last.
okay. Question 2. Was a little bit of integration in here as well. So we've got to integrate this. That was it. There was no clues to this. So it's probably not a substitution question because we would have expected some clue to that. It's going to be integration by parts, isn't it? And how are we going to go about doing this? Well, if we do it with the... That definitely differentiates quite nicely. So would that be... That's probably the nice thing to work with and see what happens as we work our way through that. So let's start with u is x squared plus 5x plus 7, and dv by dx is sine x. If we differentiate, we get 2x plus 5, that is 2, honest, and v, if we integrate sine, oh, it's sim card, sine integrates to minus cos, art. So there we go, we've got that in there. Let's put the integral together. Our integral becomes u times v, so x squared plus 5x plus 7 times minus cos x between 0 and pi. Take away the integral of v du by dx, so minus cos x times 2x plus 5 dx. I wrote that right way around deliberately. Look. Oh, I do love this bit. Ah, there's the face. Sorry. Right. Now we're going to integrate this bit, and it's integration by parts all over again. Such fun. So we'll do it the same way around. So u is 2x plus 5, and dv by dx is, or should we just, we've got minus minus here, haven't we, so we can just forget about that. So dv by dx is cos x, giving us du by dx as 2, and if we integrate cos, we get sine. So put this together, I missed out my limits there, which is a bit silly. So the integral is, right, we've got already a minus x squared plus 5x plus 7 times cos x. We've now also got, here we have minus minus, so that's plus u times v. U times v. 0 and pi. Take away the integral of v du by dx. Okay, there was a little bit of being careful about justifying what we did with the signs. Are we happy with what we did with the signs? Does that all make sense? So now we actually need to finish off the integration. So our integral becomes, what have we got? Minus x squared plus 5x plus 7 plus x plus 2x plus 5 times sine x. And if we integrate sine x, we get negative cos x, but it's already negative, so plus 2 cos x between 0 and pi. Finally, it's time to put the limits in. So if we put pi into this, well, cos of pi is minus 1. So we've got, so that's minus 1, so that gives us a plus there, times pi squared plus 5 pi plus 7. Sine of pi is 0, so that bit's 0. Cos of pi is minus 1, so we've got a minus 2 there. And then if we put 0 into this, cos of 0 is 1, so we've got 1 times, or minus 1 times, 0 plus 0 plus 7. Sine of 0 is 0, and cos of 0 is 1, got plus 2 in there. So we end up with pi squared plus 5 pi, and has that just completely, oh no it's not, it's all added up. We've got 5 minus minus 5. That's 10. And that's what we were supposed to show. Great success. There we go. Lots of fun. Oh yeah, right, hang on. And that's maths.